So this morning we're going to carry on looking at our laws of arithmetic with algebraic terms, and we're going to move on from addition and subtraction to multiplication and division of algebraic terms. Now, when you are simplifying an expression and you've got addition and subtraction, so say for instance you've got 6y take 3y plus 2x take 4x, you've got two separate pronumerals there, haven't you? You've got the pronumeral y and the pronumeral x. Now, when you simplify by adding and subtraction, the pronumeral does not change, okay? So you will, in the finished simplified expression, when you're adding and subtracting, you should still have a y term and you should still have an x term, okay? Now, if I add 3a there, you would also have an a term, but you don't have to simplify that one. So to simplify, as we've been doing, 6y take 3y is 3y. Positive 2x take 4x is negative 2x plus 3a. So you can see we've simplified the expression, but the pronumerals are the same. You had a y term in the original one, and you've got a y term in the new one. You had an x term in the original one, and an x term in the new one, and an a term and an a term. Okay, everyone with me? Now, the difference between addition and subtraction and multiplication and division is that in multiplication and division, okay, the pronumeral changes. So the pronumeral changes, and we also always end up with one term. Okay, unless there's a constant involved. Okay, if there's a constant involved, obviously that will be there. But if you're multiplying lots of algebraic terms together or dividing algebraic terms, you will always end up with one term, and the pronumeral will be different. So let's just have a look at what some of these mean. So if we've got 6m, what does 6m mean? 6 times n, that's right, okay? So that's obviously the algebraic form, that one's the expanded form, the expanded notation, okay? So if we had something like 2 times 6m, what would you do there?
12 times n, or 12m?
12m, yes. So you would look at the constant here and the coefficient here, and you multiply them together to give you 12, and then obviously it's still 12 times m, so you'd put m. So these should all be fairly easy for you because we did these last year. The only thing that changes with these simple ones is that if you've got, say, 2b times 6m, in this case we've got a coefficient and a pronumeral, and a coefficient and a pronumeral in both terms. Now, you can do it either way, really. I tend to think about the symbol first. Is it positive or negative? Well, in this case, it's going to be positive because we've got no negatives. So I think about, is it positive or negative? Then I look at the coefficients, and I multiply the coefficients. So 2 times 6 is 12 again. And then I look at the pronumerals. So b times m would be written how? Bm, that's right. So your answer is 12bm. Okay? Everyone remembering this from last year? Yeah? Yeah? Yes, okay, right. Silence. So, the only thing that's different is when we start adding some indices in, some index numbers, or when we have more than 2 things to multiply. So let's have a look at something like 3mn times 2n times 6o. So obviously we've got 3 algebraic terms, all of them, with a coefficient and a pronumeral. This one's got 2 letters in the pronumeral. Again, all of them are positive, so we know our answer is going to be positive. Look at the coefficients. 3 times 2 times 6 is
36.
36. Okay. And now then, what we've got to do is we've got to look at the, so we've got M, N, N and O. Because you've got MN there, N there and O. Now, if you write 36 times M times N times N times O, what would you do to kind of tidy that up a little bit? What would happen?
Turn N into N squared.
Yeah, so it would be M N squared O. Okay? Now, if those those questions had been in a different order and it had been O, M, N, at the end, what you would do is you would put them into alphabetical order. They were in alphabetical order already, but you need... The convention is, of course, with multiple letters in a pronumeral that we do them in alphabetical order. Okay? Right. Everyone happy with that? Okay. So the multiplication is pretty straightforward, really. Let's just try a slightly harder one. We'll have 4x squared times 3y squared times 2x squared. This is just the only thing that you need... Oh, actually, let's put a negative into it. Let's have negative 2x squared. So the only thing that really you need to be careful of here is your directed number laws when you multiply and divide directed numbers, so positive and negative numbers, and also your index laws, which we did do earlier in the year. What happens when you multiply 2 squared by 2 squared? You know, what happens to the indices? So let's just write, what's the sign going to be? Because we've got positive times negative. Negative. So we're going to have a negative answer. What's the coefficient? 4 times 3 times 2?
24.
24. So it's negative 24. And then it's not a bad idea to just write all of the... Once you get used to it, you can do it in one step. But let's do it in 2 steps now. So we've got x squared, y squared, x squared. So we've got negative 24, x squared times y squared times x squared. We can put them like that because obviously the default sign of algebra is multiplication. And if you've got letters next to each other, the multiplication sign is implied because we didn't need it from up there. So what would you do to tidy that up?
Move the x at the end, x squared.
Okay, which one?
The one on the far right.
This one?
Yeah.
Where would you move it?
We just get rid of it.
No, you can't just get rid of it. It's x squared times y squared times x squared. If we were going to write it as expanded notation, it would be this. Negative 24, x times y times y times x times x. So what will happen? Ella? Did you put your hand up? Yeah. Well done. So your index laws tell you, don't they, that you can actually add these indices if they're multiplied, and that will give you the new power. So it's 24 x to the power 4 y squared. And again, you would put the x first and the y second. Yeah? Okay? Let's try another one like that then. So we've got negative 2a squared times 3ab times negative 6a squared. So symbol first, we've got a negative times a positive times a negative. So our answer is going to be positive, yeah. So we'll put the positive. Of course, you don't need to put the positive, but it just shows that you know that it is positive. Coefficient then, 2 times 3 times 6.
36.
36. Okay. And then if we were going to write the letters in expanded notation, we've got a times a, which is a squared, ab, and a times a. Bah. Sounds like something a sheep would say. So what is our new pronumeral going to be? Taya?
A to the power of 5b.
Well done. A to the power of 5b. Is this starting to ring bells now? Are you remembering it from last year? Yeah. because when we did the last one, wasn't sure you were sure about the index numbers. So we'll just do one more. So, 6y squared times 3x4 times 12x squared y squared. So, no problems with positive or negative because they're all positive. The only problem you might have is working out what the coefficient is. 6 times 3 is 18 times 12.
196.
Beg your pardon?
196.
Well done, 196. 196, and then we've got y, x, 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 y, y. If we write it in expanded notation.
Y, 4x, 6.
Right, so we've got y squared here, y times y, x to the power 4, x times x times x times x, times x squared, x times x, times y squared, y times y. So what does that simplify to?
Y.
You don't actually have to write this bit out, of course, but it just shows you, it makes it a little bit easier to count them. Yes?
6x. Oh, 6 to the power of... No, x to the power of 6.
That's right. X to the power of 6.
And y to the power of 4.
Y to the power of 4, that's right. Okay. So everyone okay with multiplying? We are going to do a multiplying task when the video's finished. Right, so division then. Now division is, again, a process where you're going to end up with one term, okay? And one of the things that is really useful is if you get used to putting the division as a quotient rather than a division sum and writing it in expanded notation. So I'll show you what I mean. So let's have, say, 6x to the power 4 divided by 3x to the power 2. Now, you will be presented with sums like this with the division sign, okay? But my advice is if you get one like this, turn it straight into a quotient and do it in expanded notation. So the top one will be 6x, x, 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 obviously x to the power 4, x times x times x times x, and then it's going to be divided by 3x times x. Okay. Now the reason it's useful to do this is because you can then see how to cancel the x's. Because remember, if there's something on top of the quotient line and underneath it, you can cancel it if it's the same thing. So I always deal with the coefficients first, like I do with multiplication. So 6 divided by 3 is 2, okay? And now what we can do is we can look at the x's and see how they cancel. So you've got 1x there and 1x there, 1x there and 1x there. So you're left with the 2 x's at the top, so it's 2x squared. Now that just shows you how the index law works, because if you remember for division with the index law, you can just do 4 take 2 gives you your new index number, okay? Obviously as long as the pronumerals are the same. Right, so they were the same pronumeral. Let's have a look at something a little bit more complicated. So 4x to the 4, y to the 3, divided by 3xy. So again, write it as a quotient in expanded notation. So 12x, x, 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 y, 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 over 3xy. Now, once you've got used to this, you won't need to do this step. This step will be extraneous, as they say, which we won't need it. But at the moment, it's a good idea to do it because it does show you why the index law works like that. So 12 divided by 3 is 4. And then we can only cross off 1x and 1y. So we're left with x to the power 3, y squared.